we are going to be kicking off our first vlog actually.
Vlog, vlog.
And we're going to be talking about, appropriately, the beginning, because this is our first. The beginning.
The beginning.
So the beginning we're talking about is actually the Big Bang. So Big Bang.
Yes. So what's my understanding of?
Your understanding, your thoughts
on Big Bang.
Yeah.
Well, for me, I guess it was the point of beginning for matter. I guess is mine. And it was the time where the boson field was that field was created.
Yeah.
Out of there, I believe 11 or odd number of particles, of which we discovered one of them.
I'll trust you on that.
Yeah, and that's where the mass comes into thing.
Yeah.
So if you're looking to make big money in the future, invest in the boson research, because that is gonna change the world.
There we go.
So that's my thing. Is that was important, I think, for me anyway. Is that the matter actually achieving weight?
You're stalling.
I am. Okay. I'll give you the weird opening. I don't know if you remember last time.
I remember it now. I'll play this back a few times.
Yeah. So what's your thoughts?
So I read this a while back, and I couldn't figure out who exactly it was who came up with this particular theory, and so it was bothering me for a while.
Okay.
I was trying to figure out exactly who came up with this.
Yeah, excuse me.
And it was Sir Roger Penrose.
Okay.
Who looks like this. So he has a very interesting theory, and this is obviously my understanding of it, and I might be paraphrasing Bang, the whole universe and cosmology as being cyclical, right? So there are cyclical Big Bangs.
Okay, yeah.
And the theory is very elegantly simple. So you have a universe, and it expands, right? And it expands and expands and is expanding faster and faster, after this period of initial inflation.
Yeah.
Now, as the universe expands, over time the universe cools, right? And matter gets sucked up by black holes mostly.
Right.
And black holes emit radiation, Hawking radiation, and they become colder and colder.
Yeah.
And so eventually all the matter gets swallowed up.
Yeah.
And the other matter sort of dissipates and everything decays into radiation. So all you have left is radiation.
Yeah.
And so with radiation, you basically have photons.
Right. Yeah.
Now, as the universe keeps expanding, you eventually come to a point where each photon is isolated completely from every other photon.
So now,
and once you get
this
to
is
that
good. This is good.
point,
this is good.
I didn't come up with this.
Yeah, but it's still,
but once you get to that point where that photon is, more than light speed away, light distance away from anything else that it could potentially ever communicate with.
Right.
Because the universe is at that point expanding faster than the speed of light. That photon can never communicate with anything else. Yeah. And photons are timeless, right? So for photons, time stands still.
Yes, right.
So
and why? He knows why.
Well, I mean, this is like, relativity, right? So Einstein's equations.
Yeah.
So you have this photon, which basically is timeless.
Yeah.
There's no time.
Yeah.
Now, the other interesting thing is, when you think about something like size, right? Size is always relative to something else, right? Whether something is large or small depends on its relativity.
Measuring against it. Yeah.
But there's nothing else. There's only this one photon.
Right.
So is it the biggest thing? Is it the smallest thing? Who knows? It doesn't know. It loses time and it loses size.
Right. Right on.
So it's basically a singularity, or it's humongous.
Right?
Yeah. So that is basically the singularity of the Big Bang.
Okay.
Because
From
it just started from this point that
Right.
exists, that's timeless,
Yeah, yeah.
without space, without, it might be huge, it might be small.
We don't know.
We don't know.
At this point.
And that kind of, through eons, we don't know what obviously set off that
That's
photon
true.
from
Yeah.
banging.
Yeah.
But that's the theory,
Yeah.
which I just thought was the most elegant,
Yeah, that is.
explanation of
Big
what
Bang.
created the whole Big
yeah.
Bang. And so it's a cyclical cosmic event. Everything the universe is created, it expands.
Boom.
Then you got these photons, and
Booms again.
at some point it's like, well, what else can it do except to boom? It's timeless. It has all of time to do something.
Do something with it, yeah.
Right? So obviously nobody knows exactly what makes it boom, and that's the
where we at.
So anyways, I thought that was extremely interesting.
That is.
Is that the first time you're hearing that version of?
This is actually
how-
yes. In this detail, and actually paid full attention to somebody actually telling me about that, because I on like a higher level. I heard about the theory, but I never paid attention
Sure.
as much as I have today. And this is like I'm being serious.
Sure.
Yeah. So this is it. I know. So I know like where he was going with it.
Yeah.
But I never paid attention to it. I learned something. Coming here today.
I thought it was just something astounding when I first heard about it.
I love the guy's hair.
I wanted to get your sort of, first look at it and interpretation, but it sounds like you're just as astounded as I am.
I took clear, But I like his hair better, though, I tell you. He's got a head full of hair. He's got more hair than both of us put together.
So after we finish this game, our next episode will have to be about how do we grow some more hair.
Yes. If that's even possible. Hopefully we find that right follicle that bangs.
So thank you for joining us, and we will come back and talk more cosmology.